This is a short review of Module 1, Part A, quiz. I'm not going to deal with all the questions, but let's just begin with the first one. The organs of the body can be divided into hollow and solid organs. Well, this question was asking you, how about the gastrointestinal tract? Well, you know, that whole tract is can be considered one organ, but also separate organs like the esophagus, stomach, and the intestines. But it has 4 layers, and that was presented in the lecture. And the cardiovascular system has 3 layers. And you've already learned, you know, that you've got the intima, median, and adventitia of an artery. You have the endocardium and myocardium and epicardium of the heart. So there's 3 layers. But you also learned in the gastrointestinal tract that there is the mucosa, and there's the submucosa, and there's the muscularis externa, and there's the adventitia. So that's 4 layers. So I just wanted to take a moment to jog your thinking about that. And most of these questions about parenchyma versus stroma, what defines a tissue, class did reasonably well on that. Certainly tissues are not macromolecules. They're groups of cells that are similar. This just to remind you that when you're reviewing, review what stains stain what. Like silver stains reticular fibers. Hematoxin or ison will not visualize or help you visualize reticular fibers. And of course, if something stains blue with hematoxin and ison, it's the hematoxylin, a basic dye, reacting with an acid radicals in DNA or RNA and renders, for example, the nucleus blue. You should review the steps in preparing tissue, you know, fixation, embedding, staining, sectioning. So class didn't do very well on that, but we didn't change anything because after a tissue is stained on the glass slide, then you have to dehydrate it so that you then subject it to an organic compound like xylene, which then is miscible with the permalt, the resin that you're going to put on and put the cover slip on so that it can be permanently mounted and viewed in a microscope. You should also know what kind of microscope gives this image, an electron microscope, transmission versus scanning. You should know the resolution of a light microscope, and we gave you some figures to calculate that, and the formula that in the lecture should be something you should know. The microscope used to produce this is scanning. You see the electrons are bouncing off. Whereas back here on this one, it's a silhouette. The electrons are passing through the very thin specimen. But this specimen would have some bulk to it, and the electrons come down and bounce off and go in a collector tube, and then they're visualized on a cathode ray tube. So that's a scanning electron microscope. And then populations of cells differ in their rate of mitosis. So that's what this question was about. What about neurons? Well, they're static, post-mitotic. What about smooth muscle? Well, they're stable and they divide periodically. Well, reviewing that might not be a bad idea. And then cytoskeleton. You see the cytoskeleton is composed of filaments or microtubules. And they can be microtubules, intermediate filaments, microfilaments, actin, but not centrioles. Now, the basal bodies can generate, and even centrioles can generate microtubules, but the centrioles themselves, while they give rise to a component of the cytoskeleton, they themselves are not the cytoskeleton. And review inclusion versus organelles. All of these an inclusion except for mitochondria, which is an organelle. Cell surface modification with microtubules, that's cilia. Realize that stereocellular microvilli have actin. The glycocalyx is a coating on the cell membrane surface, but it's not made of microtubules. And the villi, those are in the intestine, those are projections of the mucosa with loose connective tissue. How do cells exchange ions through the gap junction? Let's just remind you of that. And then the epithelium that lines different parts of the body. We've given you that. That's what these questions were about. And so this is not to teach this again. This is just to prompt your thinking about being prepared on the midterm. What is a hyaluronic acid? It's a glycosaminoglycans. It's none of these others. And what about collagen? You learned about type 1, type 2, type 3 at least. So type 1 is either the collagen in a tendon or the collagen in a bone. And type 2 is in cartilage, and type 3 reticular fibers. Then brown and white adipose tissue. There are two names for brown, multilocular or brown. You should know those. What type of tissue in the human embryo? It could be either mucous connective tissue or mesenchyme, but not loose connective. These are all adult connective tissue terms. Masson's trichrome, best for collagen, whether it's a green stain or a blue stain. It will really, really make collagen stand out. But none of these others will highlight collagen. You will see with eosin, the collagen will be pink, but it will not stand out as remarkable as with Masson's trichrome. Carcinoma is said to be malignant when the cells invade adjacent tissues. Well, that's true. And then, you know, after 45 years of age, most tumors do arise in epithelial tissue, not in bone marrow. Most of the tumors early in life are arising from bone marrow, leukemia, lymphomas, things like that. Abnormally high proliferation of cells, well, that's neoplasia. And so I'm going to go through the rest of these fairly rapidly. I'm mainly trying to give you some reminders by just letting you look through. And then we asked some questions about WebMike. I just wanted to see if you were actually paying attention to the different tabs and tools in WebMike, and we're actually using it. Then identify the tissue within the solid line. Let's see. Yeah, I have this window small, so I just have to click on this image here, which you can do in the test, and you can do it in the midterm exam also in Part A. And now you can see what we're referring to. This is pseudostratified ciliated columnar. There's the cilia projecting from the surface of the cells, and you can see that it looks like there might be two layers of cells, but you do not see two distinct layers of nuclei. In order to call it stratified epithelium, say stratified columnar, you're going to have to see two distinct layers of nuclei, and this is not the case. So that was pseudostratified ciliated columnar. And we allowed a variety of answers because you can answer it in different ways. And this was simple columnar epithelium. So just make sure you can identify the epithelial types. There's another one this was transitional. This gives people a lot of trouble, but here, these are not cuboidal. They're clearly irregular shape. And there's only a few layers of it, but it's truly stratified. But if it was stratified squamous, the cells would be flat. If it was stratified columnar, you would see columnar cells. If it was stratified cuboidal, you would see clearly cuboidal shaped cells at the surface. So this is transitional epithelium that lines the bladder and the ureter. Okay, and here we ask, and then we gave you the micron marker, and this is almost 10 microns long, so these have to be cilia, not microvilli, because the microvilli are shorter. And here we have two types of tissue in the specimen. What structure lies under the line? Well, that's the basement membrane. And after examining the low and high, classify the tissue. It's all the stains are H&E unless we say otherwise. So this was hematoxylin and eosin. And it's collagen, the fibroblast nucleus here and here. And so that's connective tissue. And here we have identified the cell type represented by the two cells indicated by the arrows. Those are plasma cells. You see the nucleus is off center. You actually have a light Golgi apparatus. You have a basophilic blue stained cytoplasm where the rough endoplasmic reticulum is located. And you have this clock face type nucleus. So all of those add up to a plasma cell. These other nuclei, this is probably lining a vessel. It would be simple squamous cells. And these other cells with the oblong nuclei would be most likely fibroblasts. And this one here is probably a lymphocyte. You see it has very little cytoplasm and a very dark round nucleus. And here we have, this is dense regular connective tissue like that's present in tendon. And here are mast cells. You see you've got a nucleus here and a nucleus here, and you have these granules, and the nucleus is relatively in the center and granules, so this is very typical mast cell. And it secretes serotonin, histamine, and heparin. And some people thought it was fibroblasts. It secretes glycosylated glycans. Others thought it was a fibroblast that secretes collagen. And some people thought it was a mast cell, apparently. So be sure you check up on your mast cells. So that ends this. It's about 11.5 minutes long.